Greetings, Yuma High School. All right, today, volumes of prisms and cylinders, and we'll see how we can get through this quick and easy. It's going to be easier because now we understand what's a prism, what's a cylinder. We've already done this, okay? We know all the vocab already. Now, the only thing that's new is we're going to be looking at volumes, right? And then a little bit on composite space figures, all right? And I'm going to tell you that I'm really fighting with my pen tonight. So I don't know whether my touch screen's going nuts, but you may have to bear with me a little bit because things are really spotty in how this pen is working. So let's get into it anyhow. Pretty much, volume. How much space does something occupy? Okay, occupy. All right. How much water will it displace? How much air does it take the space of? Okay. So it's three-dimensional. Its units are in cubic inches or cubic meters or cubic feet or something like this. You already know how it works because I know you have already used this formula in the past. You know that a right rectangular prism, like this one shown here, has a volume that is equal to length times width times height, and again, not a big deal. You've always done that. What you've been doing in effect, don't know if you ever realize it, but you're taking the area of the base and you're multiplying it by the height. And you know what? For any prism or cylinder, you find the volume by multiplying the base times the height. Doesn't matter if it's right, doesn't matter if it's oblique, doesn't matter if it's a cylinder or a prism. You take the area of the base, multiply it by the height, you got the volume. All right? No matter what. You may read a little bit about Capillaries Principle. Not a big deal. All it's telling you, though, it really is that if two objects have the same height and the same cross-sectional area at every level, whether it's right, whether it's oblique, you're going to have the same volume. Pretty much simply put, once again, any way you look at it, area of the base times the height is going to equal your volume. No matter what it is, base times height. Cool? So a little bit of practice here. Let's just look at this triangular prism, all right? And we need to do a little bit of work to find the area of that base, all right? So I've got an equilateral triangle that's 10 by 10 by 12, okay? So what we really need to do is figure out that height. Okay, and those of you, some of you may already be ahead of me, you know that this is 6, right, from here to here. And if this is 10, we can do the Pythagorean Theorem that tells us that 10 squared minus 6 squared must be the height squared, right? And 100 minus 36, 64 equals h squared. H equals 8. So let's use that with our base of 12, 1/2. The base times the height must equal the area of the, that is a 4, the area of the triangle. Okay, 48 inches squared. With me on that? That all making sense? Alright, let's get rid of that stuff. Because real point of this lesson is not to find the area of the base base itself. Real point of the lesson, let's find the area of, or the volume of the prism. Well, once again, volume equals base times height equals 48 with a height of 18. So the volume of that guy, grab the calculator, 48 times 18, 864 cubic inches. Cool? Cool. That's what we got over there. All right, let's reset it. Let's do a cylinder really fast. Cylinders are even easier. All right, base equals pi r squared. R is 5. Pi r squared is 25 pi. Multiply that times height. Base times height is 9 times 25 pi. 225 pi is the volume of that cylinder right there, cubic inches. Okay, 225 pi, I'd be okay also if you use the decimal form, 225 times pi, 706.86 cubic inches. Either way, base times height, not a big deal. All right, last thing I got to tell you about. A composite figure is a three-dimensional figure that's a combination of two simpler figures. Okay, so here's my lunchbox. See, most of you guys don't know that I bring a lunchbox to school every day, and basically looks like this. Not really, of course, I'm making this up, but it looks like a prism attached to a half of a cylinder, right? Okay, so in order to find the volume, it's not really going to be all that tough, okay? The amount of space taken up by the half of the cylinder plus the amount of space taken up by the prism, I don't know what just happened there, but you just add up the two volumes and you're ready to go. So the volume of the prism here, I'm going to say, what the heck, if I consider that to be the base is 36, height is 10, all right? I got 360 cubic inches for the volume of the prism part. And I'm going to add that to the volume of the cylinder part, which is simply pi r squared, or 9 pi times the height of 10. But in this case, I've only got half a cylinder, so I'm going to take all of that, multiply it by 1/2, because I've only got half of the volume, right? Half the cylinder is missing. So this is going to be 45 pi inches cubed. And I add those up, 360 plus 45 pi equals 360 plus 45 pi, 501.4 inches cubed. Cool? Cool. That's how we do volumes. Now, just for fun, let me just show you how surface area gets a little more tricky. Do a little quick review on surface area. All right, surface area of the prism, the bottom part. All right, that says prism, believe it or not. All right. Remember, surface area of a prism is usually 2b plus pH, right? But notice, I'm not using this base here. If I consider this to be the base and this to be the base, notice I'm not using that top one, am I? So we're not going to consider that. All we're going to do is take the areas for the surface of what's on the surface. And that one, that's not, okay, so that one base is not going to be there. So for this particular shape, I take the area of the prism, which is only one base, the bottom, plus the lateral area, or base plus the perimeter times the height. Now that's all there, because I got all four sides for the lateral area, right? Okay, so I don't have to worry about taking anything out of there. All I know is I got one base that's 10 by 6, or 60. The perimeter, I got 32. And the height is 6, so 32 times 6. Okay, which means I've got a base for the bottom part, or I've got a surface area for the bottom part, 252 square inches now, right? So there's our bottom part. All right, our half a cylinder. Now, we figure that out. We've only got a half a cylinder. Our surface area for the half cylinder, got room for this. All right. Remember, surface area for a cylinder, 1/2. Surface area for a cylinder, pi r squared plus pi rh, right? So pi r squared, 2 pi r squared plus 2 pi rh, right? And in this case, I'm going to use both of them because I do have both bases. So let me step back on that a second here. Show you exactly what I'm going to do. Okay. So for a full cylinder, surface area is 2 pi r squared plus 2 pi r h. But for a half cylinder, I'm going to multiply that each by 1/2 because I'm only working with that part of it. So I'm going to end up with pi r squared plus pi r h. And that's actually the calculation that I'm going to do on this, all right? So follow along. Pi r squared, radius is 3, r squared, that gives me a 9 pi, plus pi r h, r is 3, h is 10, gives me a 30 pi. That equals 39 pi inches squared. All right, so we end up with a final surface area for this composite figure of 252 plus 39 pi inches squared, or 252 plus parentheses 39 end parentheses 374.5 square inches. And I hope you enjoyed that. I'm going to log off. See you guys tomorrow.